अस्सलाम वालेकुम।
वालेकुम सलाम सर।
वालेकुम सलाम।
स्क्रीन शेयर्ड।
यस सर।
चलिए ठीक है। So we are continuing our discussion on design patterns. बास साहबा ने हज़रत सुभान रज़ी अल्लाह ताला अन्हु कहते हैं कि बास साहबा ने कहा कि काश हमें ये मालूम हो जाए कि सोने और चांदी के अलावा और कौन सा माल बेहतर है ताकि हम उसे जमा करें। तो आप सल्लल्लाहु अलैहि वसल्लम ने फरमाया, अल्लाह का जिक्र करने वाली ज़ुबान, शुक्र अदा करने वाला दिल और मुसलमान बीवी जो अपने शोहर के ईमान की मददगार हो, बेहतरीन माल है। तो ये हमारे नबी सल्लल्लाहु अलैहि वसल्लम का हमारे लिए मैसेज है कि दुनिया की मामलात से बेहतर हम आखिरत की तैयारी करने वाले बने। अल्लाह ताला हमें अमल की तौफीक अता फरमाए। Okay, so the recap, we saw initial lecture, we saw object-oriented basics, then we saw a few principles, then we saw strategy pattern, and then we finally saw the generic structure of the strategy pattern. Then we covered object observer pattern, and this was the generic structure of observer pattern. There is a subject, concrete subject, observer and concrete observer, and there are important attach, detach, notify methods as well as update methods in observer pattern. Then we saw a decorated pattern. The important structure is that decorator pattern composes its parent, that is a component, that with this it gets the capability of composing any concrete component or concrete decorator, and it can add its own behavior and own states in original component behavior. And today we are going to see two patterns. One is adopter pattern, another one is factory pattern. So first of all, we'll start adopter pattern. Today we are going to meet the ducks again. So first of all, you're already familiar with adopters, electrical adopters, and we see various incompatibilities between sockets, and between those incompatible sockets we place AC power adapters. So by and large it's the same concept. What happens that you may assume that you have some existing system. It has some sort of interface, and there is a vendor class which has a different interface. One is triangular interface and the other one is circular interface. Now both cannot be directly interfaced. So what we do, we place an adapter in between. So on one side it matches the interface of existing system, and on the other side it matches the interface of a vendor class. So actually what happens, as you can see, we are gluing existing system and a vendor classes with an adapter in between. But the beauty of adapter pattern is that neither we have to change the code of existing system, nor we have to change the code of vendor class. Rather, a new code will be written for the adapter only. I hope the concept is clear.
Yes, sir.
Okay. So, our old familiar ducks are again available to us, and we know that if some species is walking like a duck and it also quacks like a duck, then it must be a duck. This is how we recognize any species. So, what change we may see that if it walks like a duck and quacks like a duck, then it might be a duck. It might be a not duck, but turkey wrapped with a duck adapter. यानी सादी उर्दू ज़बान में कि हो सकता है किसी टर्की ने डक के कपड़े पहन लिए हों और डक्स में मिक्स हो गई हो. ठीक है. So it's time to see an adapter in action. Remember our duck from chapter 1. Let's review slightly simplified version of duck interface and classes. So there is an example of duck interface. We have two methods, quack and fly. This time around our ducks implement a duck interface that allows duck to quack and fly. Okay, so the behavior is, this time behavior is not pulled out just for an example sake, but we are keeping our behaviors within a duck interface. So this is how any particular concrete duck can be implemented. So we just have to implement two methods. One is quack, which says quack, and a fly method which says I am flying. So it's a simple implementation of duck interface by a concrete mallard duck class. Now let's take a different species and we call it turkey. So you may consider this duck interface as an existing system. Now somewhere we have received a turkey. So turkey has its own behavior. Interface indicates that turkey gobbles and turkey also flies. So turkey don't quack, rather turkey gobbles. On the other hand, turkeys can fly, although they can only fly short distances. तो टर्की का भी है fly behavior, but its implementation of its fly behavior is a bit different than a duck. On the other hand, it does not have a quack behavior, rather it has a gobble behavior. And this is the bottom one is an implementation of Turkey interface by a concrete Turkey class, and the name of concrete Turkey class is wild Turkey. So the implementation of gobble is simple, gobble gobble, and implementation of fly is I am flying a short distance. Any question, confusion on this code? जी कोई कंफ्यूजन हो तो जरूर पूछ लें. Okay, so if there is no confusion, then we move forward. So up till now, we have seen a duck hierarchy. You may consider it an existing class or existing system, and there is a separate hierarchy, Turkey hierarchy. You may consider it as a vendor class. And these are two different implemented systems, and they have something common which might not be common, and the common is the fly method, but one behavior is totally different. Quack, here it's cobble, and one method signature is same, but it's again its implementation is different. So as far as implementation is concerned, the implementation is totally different. As far as similarity of interfaces is concerned, so you may say that there is 50% similarity. That is, out of two methods, one method signature is common. Okay, so if we want to make or integrate them so that they can be handled by a client code in a similar fashion, then what can we do? Let's move forward. Let's see what can we do. Okay, now let's say you are short of duck objects. Ducks कम पड़ गई हैं आपको, and you would like to use some turkey objects in their place. ठीक है, आपने इसका लाहौरी मतलब नहीं निकालना कि जी कौ कम पड़ गई हैं, देन वी मे यूज डंकी. ये काम नहीं करना आपने. ये डक और टर्की दोनों हलाल हैं. Obviously, we can't use turkey outright because they have a different interface. So let's write an adapter. Okay. Now we are trying to place a class in between the two different implementations. One implementation is of a duck and other implementation is of turkey. So we are planning to have an adapter class. So you can see on one hand, the adapter is implementing duck interface. It means that the adapter is kind of duck. So it is kind of duck, or it is a relationship with duck. The adapter is a kind of duck. On the other hand, adapter has a reference of turkey object. So on one side it is generalization, on the other hand it is composition. So this is what first of all you need to remember. And let's move forward. Let's see the code implementation. So there is a Turkey adapter which is implementing the duck interface. So first you need to implement the interface of the type you are adopting to. तो जिस तरह का इंटरफेस आप जिस तरह के इंटरफेस को आप अडॉप्ट करना चाहते हैं उस इंटरफेस को हम इंप्लीमेंट करता है अडॉप्टर. दिस इज द इंटरफेस योर क्लाइंट एक्सपेक्ट्स टू सी. इसका मतलब है कि क्लाइंट एक्सपेक्ट कर रहा है कि उसको सिर्फ डक इंटरफेस विजिबल हो, उसको ना पता हो कि कोई टर्की इंटरफेस भी है, कोई टर्की इम्प्लीमेंटेशन भी है. वी वांट टू हाइड द इम्प्लीमेंटेशन of Turkey classes behind the duck classes. So it means that client is expecting only one type of objects and that are duck type. So if client is expecting duck type interfaces or duck type classes, then our adapter should implement the duck interface. Then you can see the constructor of Turkey adapter. In the constructor, we are passing the object of Turkey, and the purpose is so that the as far as object of Turkey adapter is created, it should get the adapter the object of the adoptee class, and it will keep the reference of object in this implementation, that is the reference of Turkey. Here you can see this dot Turkey is equal to Turkey. So basically, right on the outset of the life of the object of Turkey adapter, it will get the object of Turkey and it will have reference of Turkey with it. So it means that it is composing the Turkey object. So it means that, let's see the formal explanation. Next, we need to get a reference to the object that we are adopting. Here we do that through the constructor. Okay. Now, since adapter is implementing duck interface, it means that adapter has to implement two methods. One is a quack method and other one is fly method. So in quack method, it is delegating the job to the gobble method of Turkey object. So instead of quacking, it will ask Turkey to gobble. Similarly, in the fly method, it will ask Turkey to fly 5 times. The for loop will call fly method 5 times, and the reason is that Turkey fly short distances. So it means that the fly implementation and quack implementation of adapter is different rather than pure duck, because it is delegating its task to the composed object, that is Turkey. One is turkey.gobble, another one is turkey.fly. So let's see the formal explanation. Now we need to implement all the methods in the interface. The quack translation between classes is easy. Just call the gobble method. Any question? Any question? Okay, so even though both interfaces have fly method, turkey fly is short spurt. They can't do long distance flying like ducks. To map between duck fly method and a turkey, we need to call the turkey fly method 5 times to make up for it. So we have seen the implementation of the adopter. Any question on this implementation? कोई confusion हो, question हो तो पूछ लें.
सर हमने बेसिकली ओवरराइड किया है क्वैक और फ्लाई फंक्शंस को ना.
ओवरराइड नहीं, ओवरराइड तो ये होता है ना कि अगर ऑलरेडी इम्प्लीमेंटेशन हुई है क्वैक की.
जी.
ओवरराइड उस वक्त हम यूज करते हैं जब क्वैक की इम्प्लीमेंटेशन ऑलरेडी हुई होती ना डक के अंदर, तो हम उसको चेंज कर देते हैं. तो डक तो एक इंटरफेस है, उसमें तो क्वैक का सिर्फ सिग्नेचर है. क्वैक का तो सिग्नेचर है, क्योंकि डक अडॉप्टर इसको इम्प्लीमेंट करना है इंटरफेस को, तो डक अडॉप्टर हैज टू इम्प्लीमेंट क्वैक एंड फ्लाई मेथड. अब अपनी उसकी इम्प्लीमेंटेशन अपनी होगी, जैसे भी इम्प्लीमेंट करना चाहे. तो हम यहाँ ओवरराइडिंग का कॉन्सेप्ट नहीं आ रहा, लेकिन ये है कि यहाँ डेलीगेशन का कॉन्सेप्ट है कि क्वैक जो है ये खुद कोई कोड कुछ करने के बजाय it is delegating the task to the turkey object, that instead of quacking you do what you can do. ठीक है, इसको कहा क्वैक का, उसने कहा यार क्वैक तो भी, उसने टर्की को कहा कभी आप गॉबल कर लें जो आपको काम आता है.
और सर ये
ठीक है,
गॉबल और फ्लाई जो टर्की का है ये उसकी अपनी क्लास में इम्प्लीमेंट हुए.
हाँ उस क्लास ये वहाँ पर है, ये इम्प्लीमेंट वहाँ हुआ गॉबल में और फ्लाई में. मैं वापस पिछली स्लाइड में दिखाता हूँ आपको. ये टर्की की इम्प्लीमेंटेशन थी, गॉबल की इम्प्लीमेंटेशन ये है. तो उसने कहा टर्की के ऑब्जेक्ट को जी आप गॉबल करें, ये वाला मेथड एग्जीक्यूट करें. और फ्लाई, अब उसने फ्लाई में उसने टर्की को कहा कि आप अपना वाला फ्लाई आप एग्जीक्यूट करें. तो इट इज़ अ कॉन्सेप्ट ऑफ डेलीगेशन.
ओके सर.
ठीक है, चलो गुड. एनी अदर क्वेश्चन फ्रॉम द क्लास? Okay, let's have a test drive. There is a main method. In main method, we are creating an object of concrete duck, that is a mallow duck. So it will get a reference in duck variable. Then we are creating an object of wild duck, and its reference is in turkey variable. Then third time we are creating an object of turkey adopter. But while creating the turkey adopter, we are passing the object of turkey to it, so that adopter can have a reference of turkey for further operations or method calls or delegations. So its object will be saved in turkey adopter variable. So now we have three variables. One is of type mallow duck, other one is of type wild turkey, and third one is of type again duck. Turkey adopter is a kind of duck. ठीक है, और mallow duck भी एक तरह की, it is also kind of duck. तो अब लेट्स सी हम कैसे इसको टेस्ट कर रहे हैं। हम स्ट्रेट अवे पहले टर्की को कहते हैं जी टर्की डॉट गॉबल, टर्की डॉट फ्लाई, विच इज़ वेरी मच डूएबल, क्योंकि हमने टर्की का ऑब्जेक्ट क्रिएट किया हुआ है, तो वी कैन कॉल इट्स मेथड्स गॉबल एंड टर्की। बट दिस इज नॉट, it is depicting an a regular implementation that we are directly calling a turkey. So there is no role of the adapter in this code. But next onward, we have written a small method test duck, and we are passing it a reference of a duck, and within a test duck we are calling quack and fly method of duck, because duck interface, any class which is of kind duck, it has to implement quack and fly method. So we have created a small method test duck. Whenever we'll pass object of a duck, it will execute quack and fly, and this method we are going to make use in the upper code. That is first of all, the original, this is Mallard duck. This is duck object in which concrete duck is placed. So we are calling test duck and passing object of original duck. So obviously it should execute because it expects an object which is of kind duck. So it has to work. Second time, we are calling the test duck method again. And this time, instead of original duck, we are passing the object of turkey adapter, and it will accept the turkey adapter because turkey adapter is also kind of duck, and test duck method expects an object of kind of duck. So because turkey adapter is also kind of duck and this duck is also kind of duck, so both objects can be passed to the test duck. So once we will call the turkey adapter object, it will call its quack, which will delegate which will in turn call the gobble object, a gobble method of turkey, and the fly method has a for loop which will call the turkey fly 5 times. Let's see, here is the explanation. First of all, we are creating an object of Mallard duck.
Excuse me,
This
sir?
is a statement. Ji?
सर लास्ट स्लाइड पे
जी
सर ये लास्ट स्लाइड पे जब आपने ये टर्की अडेप्टर का इंस्टेंस क्रिएट किया है ऑफ काइंड डक, इसकी जगह अगर हम डक की जगह इसको टर्की अडेप्टर की ही काइंड रखते तो ये फिर टर्की का ऑब्जेक्ट बन जाता, मतलब उसमें फिर टर्की के ऑब्जेक्ट डायरेक्ट मेथड्स डायरेक्ट कॉल हो रहे होते अगर हम इसकी काइंड वो रख देते।
सेकंड स्टेटमेंट की बात कर रहे हैं?
सर नहीं, थर्ड स्टेटमेंट की जो हाईलाइट हुई हुई है सर, इसमें अगर डक की जगह हम मैं टर्की अडॉप्टर लिख दूं कि उसकी जो काइंड है वो टर्की अडॉप्टर बन जाए, तो फिर ये टर्की अडॉप्टर का ये टर्की का ऑब्जेक्ट बन जाएगा उस तरह का एग्जैक्ट इन बिहेवियर। अगर इस पे
ये हाँ, फिर न्यू हाँ, ये डक, इसको डक टाइप का ऑब्जेक्ट बनाना पड़ेगा ना हमें, इसे डक अदरवाइज ये एक्सेप्ट नहीं करेगा ना फिर इसको।
सर बिल्कुल वो अगर बिल्कुल सर वो एक्सेप्ट नहीं करेगा और टेस्ट डक में फिर इसको एरर देगा, नहीं लेके जाएगा सर।
एक्सपेक्ट कर रहा है काइंड ऑफ डक, लेकिन ये ऑब्जेक्ट जब यहाँ इसको डक नहीं लगाएंगे तो ये काइंड ऑफ डक नहीं बनेगा ना, तो ये फिर टाइप कास्टिंग वगैरह एडिशनल करनी पड़ेगी, फिर सही कार्रवाई करनी पड़ेगी इसको। क्योंकि अभी स्ट्रेट अवे डक काइंड है तो स्ट्रेट अवे एक्सेप्ट कर लेगा। इस तरह की सिचुएशन में फिर आपको कई दफ़ा फिर टाइप कास्टिंग करनी पड़ती है, वो तो कम्प्लेक्स हो जाएगा कोड, इस तरह का काम करना पड़ेगा। सही है, चलें टेस्टिंग भी करके देखिएगा क्या करता है। मेरे ख्याल में टाइप कास्टिंग करके यूज़ हो सकता है, वैसे नहीं होगा। ठीक है जी। So here is a further explanation of the code. This is the first statement, MailerDuck, new duck. So you can see that we are creating an object of MailerDuck. Then in the second statement, we are creating object of wild turkey. Then in third statement, we are creating an object of turkey adopter, but we are also passing the turkey to it, so it will get a reference of it. Now in this statement we are calling the gobble and fly methods of turkey object. So here you can see we are calling gobble and fly methods of turkey object. So it means that turkey object can be since it has object has been instantiated, so we can directly call its methods if we need. On the other hand, we have here we are calling the test duck method and passing a duck object. So once we are passing a duck object, test duck will do two things. It will call quack of MailerDuck, and then it will call fly of MailerDuck, because we are passing the concrete object of MailerDuck. Then in the next code, since we are passing the object of turkey object, and this is the turkey adopter, rather turkey adopter. This is turkey adopter. So once we will call quack against turkey adopter, in turn it is going to call the gobble of wild turkey, and next it is going to call the fly method of turkey adopter, but fly method is going to call the fly method of wild turkey 5 times. So this is further explanation of the code. You can also see object. This is a class, we can run it. So quack, I am flying. These two statements are for yes. First of all, turkey says these two statements are creating these two outputs, and test duck is printing these two statements, and test turkey doctor is printing these 6 statements. If you want try to see the main method for so this is main method. You can create its implementation. So this test duck is calling the quack and fly against a duck interface, and again this one is going to do the same. it is going to call it against the interface. ये जो implementation है sequence diagram की, ये further यहाँ से आगे concrete objects की तरफ नहीं लेके जाता. बस अगर आपने reference के अपने इंटरफेस के अगेंस्ट कोई कॉल दिया तो यहीं पे खत्म कर देगा. बिकॉज एट कंपाइल टाइम वी डोंट नो दैट विच कंक्रीट ऑब्जेक्ट वी आर गोइंग टू पास एट रन टाइम. सो कंपाइल टाइम की रिप्रेजेंटेशन ये वाली सीक्वेंस डायग्राम करती है. जो दूसरी सीक्वेंस डायग्राम जो मैंने आपको दिखाई है वो रन टाइम की इम्प्लीमेंटेशन भी शो कर रही होती है. सो डिफरेंट इम्प्लीमेंटेशंस आर डन बाय डिफरेंट वेंडर्स. Okay, so let's review the adapter pattern. What we saw in the adapter pattern. Now that we have the idea of what an adapter is, let's step back and look at all the pieces again. There would be a client. The client is implemented against a target interface. And the target interface in our case study is duck. So client is going to send a request to the target interface, that is, it is going to send its request assuming that it is talking to a duck interface, and target interface is duck interface. The adapter implements the target interface and holds an instance of adoptee, but adapter has a reference of adoptee. So whatever request that adapter will receive, it will translate that request and send it to the adoptee, and adoptee is going to, here in our case study, adoptee is a turkey, and the translated requests are going to be executed. So adapter is in between client and adoptee, and client has no knowledge that there is a code, a separate code which is hidden behind the adapter or hidden behind the target interface. Okay, here's how the client uses the adapter. The client makes a request to the adapter by calling a method on it using the target interface. The adapter translates that request into one or more calls on the adoptee using the adoptee interface. And then client receives the results of the call and never knows there is an adapter doing the translation. So this is a generic structure of adapter and a definition. So as turkeys and desi adapters, let's get real look at the official definition of adapter pattern. Adapter pattern converts the interface of a class into another interface the client expects. The adapter lets the class work together that could not otherwise because of incompatible interfaces. So there is a concept of client, there is a concept of target interface, there is concept of adapter, and there is concept of adoptee. So there are four concepts involved in the adapter pattern. Adapter is kind of target interface, and adapter composes object of adoptee. Now, despite having defined the pattern, we have not told you that whole story yet. There are actually two kinds of adapters: object adapters and class adapters. This chapter has covered object adapters, and class diagram on the previous page is a diagram of object adapter. तो पीछे पूरी जो हमने एग्जांपल देखी है, that example is basically an implementation of object adapter. अब अगर क्लास एडॉप्टर हमने इम्प्लीमेंट करना है तो देन उसमें हम ये करते हैं कि जो एडॉप्टर होता है it implements target interface as well as adopter interface, और इनकी आपस में क्योंकि दोनों इंटरफेसेस विजिबल होते हैं एडॉप्टर को, तो वो यहीं से ट्रांसलेशन का कोड लिख के तो एडॉप्टी रिलेटेड कोड एग्जीक्यूट कर सकता है। Instead of using composition to adopt the adoptee, the adopter now subclasses the adoptee and target classes। अच्छा, यहाँ पे ये देखें कि जो एडॉप्टी की इम्प्लीमेंटेशन होगी वो ऑलरेडी यहाँ पे होगी। यहाँ पे देखें टारगेट इंटरफेस इटैलिक में नजर आ रहा है, इट मीन्स इट इज ओनली अ सिग्नेचर, बट एडॉप्टी इज अ क्लास, इट माइट बी अ क्लास, और उसकी जो इम्प्लीमेंटेशन है वो यहाँ पर होगी। ये सिर्फ इनहेरिट करेगा इम्प्लीमेंटेशन और यूज़ करेगा उस इम्प्लीमेंटेशन को, अगर क्लास एडॉप्टर हम यूज़ करते हैं तो ये बताएं, ये जावा में इम्प्लीमेंट हो सकता है?
हो सकता है सर, हो सकता है सर, क्योंकि मल्टीपल पेरेंट्स उसके मतलब दो एब्स्ट्रैक्ट क्लासेस को इकट्ठा एक्सटेंड नहीं कर सकता, लेकिन एक क्लास को एक्सटेंड और एक को इम्प्लीमेंट कर सकता है।
ठीक, सही सही, चलें ठीक हो गया, आगे चलते हैं। सो दिस इज व्हाट हैपेंस इन the class adapter. There is a client, there is a target interface, it might be a duck class and it might be a turkey class, and which will have a specific request, and adapter is basically implementing the method of request method of here. So there is a slight implementation detail, तो इसकी इम्प्लीमेंटेशन नहीं डिस्कस मैं करूँगा, इसको आप एक्सपेरिमेंट करें एज होमवर्क। अच्छा जी, तो अच्छा ये देखें, दिस इज अ नोट, द क्लास एडॉप्टर यूजेस मल्टीपल इनहेरिटेंस सो यू कांट डू इट इन जावा। ठीक है, लेकिन मैंने वैसे इसको करके नहीं देखा, लेकिन जो आपका आर्गूमेंट है वो ठीक है। अगर ये इंटरफेस है तो ये कंक्रीट क्लास हो सकती है, और वी शुड बी एबल टू इम्प्लीमेंट इट बाय कीपिंग वन एज इंटरफेस एंड अदर वन एज अ क्लास, तो इम्प्लीमेंटेशन हो जानी चाहिए। तो ये थोड़ा सा आप होमवर्क करेंगे और देन वी विल डिस्कस इट इन द नेक्स्ट क्लास, इम्प्लीमेंटेशन। ठीक है जी,
राइट,
ओके ओके। ये इट इज सेकंड अडॉप्ट इम्प्लीमेंटेशन ऑफ अडॉप्टर। इसके लिए हम थोड़ी सी 5 मिनट की मैं ख्याल है करके इसको डिस्कस करना शुरू करते हैं। इट इज 6:29, I think we can have 10 minutes break. We will rejoin at 6:40 पे हम ये वाली अगली एग्जाम्पल को देखते हैं।